Hello, hello. We are doing 2.2, which is adding, subtracting, and multiplying polynomials. Our goal in this unit is to be able to take any polynomial that we talked about last time, any quadratic, cubic, quartic, quintic, whatever, any degree polynomial, and be able to add them or subtract them or multiply them. So a lot of this is a review. I will try to point out places where students make mistakes so that you can be aware of that and hopefully avoid those mistakes, not think that they are a good idea, and perhaps you want to try them as well. So thank you for watching, and I appreciate you being here. Okay, so first let's review. What are like terms? Like terms are terms that have the same variable and the same power. So let's write that down. So if you had an x and an x squared, those would not be considered like terms because they don't have the same power. If you had both of them being x squared, then those would be considered like terms. The number in the front doesn't matter as much, just the variable and the power. If you had 3x and 4y, those would not be considered like terms because one variable is different than the other, even though the powers are the same. So they have to be both the same exponent and the same variable in order for these to be like terms. And if that's the case, you can add these and subtract these variables, these units. So if you're looking at example A, if I'm trying to add, we're taking these two polynomials. This is a polynomial, this is a polynomial, and we're adding them together. In order to do that, you need to figure out what the like terms are. So looks like you've got a cube here and a cube here. You've got a square here. It's a -4 and oh, not that one. That's not a like term. Then it looks like I've got a 5x and a -11, and then this 2 off at the end can't combine with anything. So when I do this, I like to make sure that I'm adding them with the largest variable first. It just will automatically put it in standard form, which is kind of nice. So if you have 7x cubed and 3x cubed together, it's kind of like saying 7 oranges and 3 oranges. You would have 10 oranges total. Then there's nothing to combine with that -4x squared, so just tack it on. So that's been taken care of, that's been taken care of, that's been taken care of. Then 5x minus 11 would be a -6x. Bam, bam, and then plus 2. And that's it. Let's do it again. I like to look at the like terms first, highlight them, underline them a certain way. I have a highlighter, but I have been known in the past to maybe underline once and underline twice. If it's different, that would work as well. So 9x squared minus 5 would be 4x squareds. 7x plus, -7 plus 2 would be a -5x. And then just that plus 12 at the end. And that's how you add polynomials. You're just adding these like terms together, writing it in the most simplified form. So for example 2, we're going to now subtract. The thing is, I don't want to just subtract this piece. I want to subtract the entire thing. So I need to subtract the 4x to the 4th, and I'm going to subtract a -9, which those negatives would cancel. And then I'm going to subtract the 7. You want to basically look at that as like you're distributing a negative to each piece after the parentheses. And once you do that, now you can just take each of the pieces from this first polynomial and the last polynomial and simply add them together because you've distributed that negative through all of the polynomials on the far right. So looking at this, it looks like I've got a 6x to the 4th minus 4. No cubes. I've got a couple squareds, and then I have an x, and I don't know how to mark this. We'll just do it with a diagonal line. I don't know, like that. I don't know, maybe put a triangle around it. So when I'm adding my like terms together, 6 minus 4 is 2x to the 4th. Bam, bam. And then I've got a -2 plus 9 would be a plus 7x squared. That one's gone, that one's gone. Then you've got that plus 3x and minus 7. Typically, students will make a mistake on this question. they'll just subtract this and leave all of the other signs the same. We have to be careful because we want to subtract each of these pieces. So to do that, we want to make sure we're looking at that subtract on all of those. So what do we have? Oh, it looks like we've got a couple things going on in there. Let's just distribute the negative. So a negative 7x cubed minus 2x cubed. So distribute that negative here, distribute it here, distribute the 3x. We're subtracting that 3x. And once we do that, we can just combine. Now, here's some warnings. I have seen students just try to like sneak in negatives here. The problem is when you just sneak those in and you don't rewrite them, you're more likely to make a mistake. And we want to avoid that at all possible. So my pro tip is to completely show that you're distributing the negative, rewrite it, cross out what you don't want anymore because you've now distributed a negative, and then continue from here. If you just try to sneak little symbols in, you're more likely to miss that little minus sign, or it just gets messy. So rewrite that so you don't make mistakes later. And then we just look at our like terms. It looks like these two actually combine. So I've got a negative 9x cubed. So gone, gone. And then there's not another squared, so we'll say plus 5x squared. That's gone. Plus 4x, because we're going to combine the 7 and the minus 3, and then minus 8. Okay, if I were you, I would pause the recording. I would jump onto my homework, do a few of these problems. We've gone through add and subtract, and I don't have the homework in front of me, but probably a relatively large portion is on add and subtract. So try those, check the answers, make sure you're getting them right, and then come back to the multiply. There are a few things specifically that get kind of messy when you start multiplying. So welcome back. Here we go. Now when I'm multiplying, multiplying is like a big distribute game. We can multiply something through. If I just had, say, 4 times x minus 2, the 4 is being multiplied to the x, and it has to be multiplied to the 2. And so we use what's called the distributive property to show that I could multiply the 4 to both of those pieces, and it would be 4x minus 8. So then here, when I multiply this out, I'm going to say the 2x needs to distribute to both of those, and the 3y would distribute to both of those as well. Sometimes you see the word FOIL. The word FOIL only makes sense in a couple of these instances though, because it starts with first, outside, inside, last. We actually have used the word FOIL, but to factor when we were factoring. So yeah, let's get started. Let's distribute the 2. Now we have to multiply it to both of the pieces in the other parentheses. So 2x times 7x would be a 14x squared. 2x times a negative 4 would be a negative 2 times 4 is 8 xy. And we've distributed the 2x. Now we're ready to distribute the 3y. So multiply the insides together. 3y and 7x would be a plus 21 xy. And then minus 12y squared. 3 times 4 is negative 12, and then the y squareds. Something you have to remember is when you multiply powers or multiply variables, you add the exponents. That's kind of a key thing to remember on these problems. Okay, so now we just have to combine like terms. It looks like the 14x squared can't combine with anything because there's no other just x squareds. These two right here both have an xy, so 21 minus 8, 20 minus 7 is a 13xy. And then minus 12y squared. And there we have it. Good, let's try that again. This time, this is the reason why FOIL doesn't work as well, because FOIL stands for first, outside, inside, last, and that only works if you've got a binomial multiplied by a binomial. On this one, If we did first, outside, insides, last, we would miss this 9x completely. So we don't actually want to use the idea of FOIL. We want to use the idea of distributing to get us through these problems. So if I did that, I'm going to distribute the x first, and then I'll distribute the -5 next. So let's go. X times 4x squared would be 4x cubed. X times a 9x would be a 9x squared. And then x times a -1 is a -x. And then keep going. So -5 plus 4 is a -20x squared. Now, you could write that here, but sometimes I like to stack, and this will actually help us for our next section. I like to stack everything that has common variables. So in the end, all I have to do is add your columns together and you're done. So let's keep going. I've got a -5 times a 9 would be a -45x, and then plus 5. So add the columns. I've got 4x cubed minus 11x squared minus 46x, and then plus that 5. So just be really careful. Don't go too fast. Try to line up your variables. It'll make it a lot easier to keep everything straight. And let's keep going. Part C and D is where we see people make a lot of mistakes, specifically part C. In fact, in Secondary 2 last year, we put one of these on almost every other test because so many people make a mistake. A lot of people will try to do something like this. They try to square the 2x and call it like a 4x squared. They try to square the -5 and either call it a plus or a -25, and then they're done. Here's the problem though. Is this equivalent to what we need it to be? Well, what if we did it with numbers? What if we said, I don't know, maybe 6 plus 4 squared? So this is just a side example to see if we can prove that squaring each of these individual terms doesn't actually make sense. So if you're writing stuff down, now would be a good time to just stop, listen, enjoy, and then we'll go back to writing stuff down in just a minute. Well, I know if I were to do it this way, 6 plus 4 is 10, and 10 squared is 100. So I know the value of this bugger right here has to be 100. Used order of operations, I did that correctly. So what happens if we try to use the method that a lot of students try, which is to square each of those pieces? If I were to square the 6, I would get 36. If I were to square the 4, I would get 16. And when I add those together, I only get 52, which is not equal to 100. So I hope that shows you that squaring the two numbers is not the same thing as what you're supposed to do, is properly doing that. If you see a squared, another way to write squared is 2x minus 5. It's the same number multiplied by itself. I hope that last little demonstration makes sense. It's hard to explain it when I can't see your faces. And by the way, if this is still 2021 and I'm not reusing my video, I really appreciate the emails that have come in. It's been a hard couple days and we're still not out of the waters yet. So at least I got to warn you on Tuesday that I wouldn't be at school. My daughter's fine. She's been I don't know. She's back from the hospital but she's starting to throw up again. So all sorts of panic and frustration are inside of my veins right now. Anyway, moving on. If it's not 2021, you don't know that my daughter just had appendicitis and had surgery and whatever. Anyway, I'm done. We're moving on now. Okay, so what do we have to do? Also, side note, if you're not into my videos, I do like to randomly talk about nothing. This wasn't nothing, but sometimes I get off task and you just have to deal with it. Back to part C. Okay, if you rewrite that twice, it's a little bit easier to see what you have to do. So let's multiply. 2x times 2x would be a 4x squared. 2x times a -5 would be a -10x. And depending on what you want to do, I, again, like to stack my variables. I didn't do that on part A, but I'm going to here. -5 times a 2x is a -2x. And -5 times a -10 is a positive 25. So add those together, I would get 4x squared minus 20x plus 25, and that is not what we had written out before I erased it. Ta-da! So the key thing is when you see a binomial squared, please make sure you rewrite it so that you can properly multiply it out. And if that's one that we are harping on, like you have to know how to do this problem, please remember you have to know how to do that problem. Okay, great. Part D. Now, this is where you have multiple binomials being multiplied together. A common mistake is to take the x and just start multiplying through all of them. Take the 1, start multiplying through all of them. Take the x, start multiply. We want to be very careful how excited we get to distribute things through. Why don't we decide 2 of the binomials, multiply those together? I like to pick the last 2 simply because when I get to the next step, I like to have the binomial be in front. Just a small pro tip. I like to pick the last 2. The numbers seem to work out a little bit easier for me. So let's multiply it out. We have x times x is 2x squared. X times 9 is a 9x. Multiply the insides. -7 times 2x would be a -14x. And then last would be a -63. So we would get 2x squared minus 5x minus 63. And that's just the last 2 binomials multiplied together. You have an x minus 1 in front. And now you do it again. This time we're going to distribute the x and then the -1 through. So x times a 2x squared would be a 3x cubed. No, it wouldn't. Try that again. 2 times 1 is a 2x cubed. Goodness gracious. X times a -5x would be a -5x squared. X times a -63 would be a -63x. Now let's distribute that -1. -1 times 2 is a -2x squared plus 5x and plus 63. Okay, I'm running out of space here, but I think we can finish this off. Let's add those together. You would get 2x cubed minus 7x squared minus 58x plus 63. And that's it. So be very careful when you see those. 4 different types of multiply questions, some a little bit harder than others. Let's move on. Example 4, determine if this statement is always, sometimes, or never true. The product of 2 binomials will be a trinomial, meaning if I multiply 2 numbers together, so binomial, binomial, can I get a trinomial? Always, sometimes, or never. Well, if you look above us, I mean, just any of those examples almost, well, I guess A and C. Example C has 2x minus 5 and 2x minus 5. Actually, let's just make that a little bit more simple and get rid of the 2. Why don't we just call it x minus 5? If I multiply those together, you would get x squared minus 5x minus 5x. Actually, that's going to simplify to be one term there. And then plus 25. So you would get x squared minus 10x plus 25. So if I multiply 2 binomials together, could you get a trinomial, something with 3 terms? Yes, you could. So the answer is not never, because we just have an example right here, which I'm going to move over, of multiplying 2 binomials and getting a trinomial. It doesn't say they have to be different, but there we go. Now, if I can come up with an example of when I multiply 2 binomials together and not get a trinomial, either get a monomial or a binomial, then I could say it's not always. It's very hard to prove never. It's very hard to prove always. but I can prove sometimes. All I have to prove, or all I have to show, is a time where it does work and then a time it doesn't work. Can you think of an example of where I would multiply two numbers together and one of the terms, either the middle term or the first or the last, would cancel? And I wish I were in class because it's better if we can start throwing out ideas. What if I had x minus 1 as my first binomial? What would the other one have to be? Well, we know if it was x minus 1, we would have something very similar to this, so that's not going to work. If we had x minus 0, then technically that's not a binomial, so it has to be a number. What if we had x plus 1? X times x is x squared plus x minus x. Look what's happening here. Minus 1. What happens to this polynomial? The inside numbers cancel. This actually is an example of difference of squares, right? So what I've shown here is, again, the first half. This is an example where it does work, so I wouldn't be able to say never. This is an example where it doesn't work. I take two binomials and I don't get a trinomial. So I can't say always, which means determine if it's sometimes, always, or never true. It's got to be sometimes. It depends on what polynomials you're multiplying together. And that's almost all that we're doing today. The last bit that we're doing is the exact same thing, except for it's in function notation. So function notation is where I'm using functions. So these f of x's, or g of x, or h of x. G, f, and h are the three most common. F is the most common because f for function. It's one of my favorite f words. But then g would be the second most common. And sometimes if you're dealing with specific examples, like you could say the height over time, you might see that if it's like a rocket problem that's being shot out of the air or something. Or you could say the profit out of time, so maybe you're doing a business model, or the temperature over time, so Celsius or Fahrenheit or something, I don't know. And there's a lot of different functions you can do. But in math, like generic math, we usually just use f and h and g. Please note the notation. This right here says you take your f and g function and add them together. That's all this says. This means the variable you're using is x. So please note, here it is, error alert. The x in this part right here does not mean that you multiply your final answer by x. It's just the input variable that you're using. Just like before, if I said p of t, like the profit over time, the input variable would be t, time. So we're just saying x is the variable. This right here stands for, take the f function, subtract the g function. You don't multiply it by anything. F times g, another notation for that is this, f times g. And then we're not doing this today, but f over g is the same thing as f over g. So that's the notation for division. And then we have this extra thing because when you divide numbers, you introduce an excluded value. That's not the topic for today. We won't worry about it. Okay, so again, do not multiply the entire thing by x when you're done. Please remember this moment. Somebody's going to try it. I don't want you to. Okay, here we go. So this right here, we're doing the same things as before. This says take the f function, add the g function. The variable you can expect to see is x. That's all. So the f function, 2x squared plus 3x plus 1. Hold on. Add the g function. And you could, if you wanted right now, just line up your like terms. You have to be careful though. Maybe I'll change my mind on that one. You have to be careful because if it were a subtraction, things can get messy. So just be very careful. This is just a regular addition problem though. Take the leading term, then you have your linear terms, then you have your constant term. So if we add those together, you would get 2x squared plus 4x, and then the one's canceled. That's it. Okay, let's look at the h minus f function. The h function is 2x minus 5. Never a bad idea to put parentheses around it as you are writing it down. So the f function is here, the g function is here, and we are subtracting those. Just like before, we want to distribute the negative. We are going to subtract all of those pieces, not just the first piece. So we need to subtract the 2x squared, we need to subtract the 3x, and we need to subtract the 1. And once we do that, you can ignore the original function. Take the 2x minus 5 with it, and let's just combine like terms. So I've got that negative 2x squared plus 2 minus 3 would be a minus x, and then minus 6. Fantastic. Okay, h times f of x. So the h function is 2x minus 5. The f function is 2x squared plus 3x plus 1. Take a minute, try it. Pause the video. Give it a shot. See if you can do it on your own. When you multiply it out, you would get 4x cubed plus 6x squared plus 2x. Then let's distribute that negative 5, negative 10x squared minus 15x minus 5. Combine them all together. And there you have it. Okay, last one, part G, D, whatever this is. Okay, the G function is x minus 1 multiplied by the H function, 2x minus 5. Again, pause the video, see if you can do this on your own. Here we go. 2x squared, distribute, minus 5x, inside, minus 2x, plus 5. Combine all my terms. What do we get? 2x squared minus 7x plus 5. Just add those all straight together. And that's it, you guys. So, can you do it? Can you add two polynomials together? Can you subtract polynomials? Do you remember to distribute those negatives? Can you multiply two basic polynomials? Can you do it when it's written like this with something squared? Can you do it if there's more than one? You'll be seeing all of those on your paper homework as well as your online homework. So be very careful as you're manipulating these numbers. Watch the negatives. There's several places to make mistakes, but you guys are awesome and you can do it. Have a good day, you guys. See you later.